In addition to the sun and the planets, we have other objects in the solar system that we're going to talk about, and the first is the asteroids and the asteroid belt. So we're going to look at this belt that happens between Mars and Jupiter. There are some theories about how this asteroid belt was created. One of those is that there was a planet that started to form because it's at about the right distance. As we look at the distances as they increase between the planets, the asteroid is actually at a perfect distance for another terrestrial planet to have formed within the inner planets before you get out to those gas giants. And the hypothesis is that a planet formed, but it hadn't completely hardened and coalesced yet, and it got hit by another planetesimal, okay, another or protoplanet, and it actually shattered it and broke it into all these little pieces. And while it hadn't cooled down completely, it had cooled down too much for it to go back through the planet building process again, and it left behind all these chunks. A lot of the minerals and the that are in the asteroids that have fallen to Earth are very similar to the minerals that are on Earth, and that's another support for that hypothesis, is that the composition is very similar to the rocky planets as well. So there's tons of asteroids that are in the asteroid belt. They've got particles of all different sizes, and what happens is that sometimes they either hit one another because they're not in a standard orbit like the planets are, and so sometimes they hit one another, and when that happens it knocks them out of their orbit, and that whole object in motion stays in motion thing starts to occur, and it starts to get pulled in by the gravitational pull of the sun, and sometimes that can cross the path of our planet. And when it does, if it passes really close to our planet, then it's called an Earth grazer. Earth grazers tend to not hit the sun, or excuse me, tend not to hit the Earth. They burn up in our atmosphere a lot of times. We call these falling stars as they burn up through the atmosphere. But they're still orbiting around the sun, but they're not in that elliptical orbit anymore, usually because they've gotten knocked out of it. So we have the same piece of rock that can be called lots of different things. So if a chunk of rock gets knocked out of the asteroid belt and it's still out in space, it's called a meteoroid. So it's out in space, big chunk of rock is going through. Once it goes through our atmosphere, it's called a meteor. That the friction of our atmosphere tends to make it look like it's on fire, which is what it is. That's why we call it the falling stars or the shooting stars. And it tends to break up as it comes through our atmosphere. It slows it down, breaks it into smaller pieces. Sometimes they explode in the atmosphere. They can be very dramatic. You can look out on YouTube and look for meteorite falls. There was one in Russia last year that was pretty spectacular. If it hits the ground, if it actually makes it all the way to the ground, it's called a meteorite. And we do have two different kinds. We have iron meteorites, which is this one over here, and it looks metal. The kind of deformed look to it is because it got melted as it came through the atmosphere. The other kinds are the stony meteorites, and they look like our Earth rocks because they're made out of the same kind of stuff. A lot of times, though, they'll have a kind of a they call a fusion crust on the outside. It'll look a little bit burnt because of if it was on the outside bit of the meteor as it came through the atmosphere. They can fall, and they find them in all different sizes and shapes. When they cut them open, some of them are pretty cool. So this is an example of an iron meteorite. They find a lot of the same kind of minerals that we find here on our planet. So we have fluorite, and we have a lot of the same kind of stuff that we find here. It's just in a different kind of matrix because it was out in space. When we have a comet that goes by, and we'll talk about a comet in just a minute, but a comet has lots of bits and pieces in its tail. And as the comet goes closer to the sun, it starts to warm up, and it starts to release some particles. And the little bits and pieces that the comet leaves behind get caught in by our gravitational pull, and they fall through the atmosphere. And it's called a meteor shower. So it's really not meteors at all, but it's bits of a comet. Which here's our comet. So our comet is the dirty snowball of our solar system. So they start out past the orbit of Pluto in what's called the Kuiper belt, and it's way out here beyond the orbit of Pluto. Pluto is one of a number of dwarf planets, and they're called Kuiper belt objects that there's lots of stuff that's left over. So it was way too far out from the sun to actually condense into anything and become planets or anything like that. But it's still a big, if you can imagine, a big area of rock and debris and ice and stuff like that, all kind of circling outside of our solar system. And that's where comets come from. So they get pulled in by the gravitational pull of the sun. They usually have a really elliptical orbit. So our planets, most of our planets, they are orbiting on a little bit of an ellipse, but this one has a really elliptical orbit. And so we see them every once in a while, depending on the comet. So here's Halley's Comet, and Halley's Comet actually shows up every 76 years. Um, and so they kind of we don't see them very often. This one's Halley's, but Halley's we see every 76 years. So we won't see it sadly again in my lifetime because it showed up in the mid 1980s. So it won't show up again until 2060-ish, somewhere around in there. So the front part of the comet is called the comma, and it surrounds the nucleus, which is made up of that ice and um, frozen methane and ammonia and that kind of stuff, and some rock and everything. And then the tail stretches behind it. When the comet is way out here, it doesn't have much of a tail. It's pretty much just the comma part. The tail gets longer as it gets closer to the sun because it starts to heat up and it starts to melt the ice, and it starts to release that cloud of gas that comes behind it. So it has a short tail back here and it has a longer tail as it goes around the sun.